Hello folks, we are taking the second part of the exercise 1.1. We have already finished the question number 1. Now we are going to the later questions and let's see how we are able to do it. Question number 2 of this exercise 1.1 says that it gives us a set A which is having an elements 1, 2, 3, 4, 5, 6. Insert the appropriate symbol. That symbol is belonging and not belonging in the spaces provided. So in this we will also get ourselves revised about the concept of a symbol of a element belonging to the set. Here they give us a set A with elements 1, 2, 3, 4, 5, 6. Because we have the set with so many elements, this kind of representation of set is also called as a roster form or listing method where things are listed that way. Now, because these are the elements, these are the members of the set. The elements of the set means the members of the set. So, what all are the elements? 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there. If it's an element of the set, we represent it by a symbol like this, which is belongs. It says that it is belonging to the set. If it doesn't belong, then we write the symbol and strike it off, showing that it doesn't belong. For example, the element 1 is belonging, 2 is belonging, 3 belongs, 4 belongs, 5 belongs and 6 belongs. But an element like 7 doesn't belong, or an element like 10 doesn't belong, an element like 100 doesn't belong. That is the meaning of belonging and not belonging to the set. On the basis of this definition, they give us certain things to fill up, and there are some blanks given. We have to fill the blanks and see what the answer comes up like. In the first subpart, they ask us 5 and A is given. They ask us to fill it up and they ask us to find out what it is. Let's get the things written and then we'll have it filled up. 4 and there is that relation with A. Then we have 2 and its relation with A. And then we have 10 in relation with A. 5, whether it is belonging to the set, it's very clear. 5 is there in the set, so it's belonging. Whether 8 is there, it's not there, so it doesn't belong. Whether 0 is there, it's not there, so it's not a member, so it doesn't belong. 4, whether it is there, it is there, so it is belonging. 2, whether it is there, yes, it is there, so it's belonging. 10, it's not there, it's not a member of the set, so therefore we write doesn't belong. So this is what they are asking us, whether it is belonging or whether it is not belonging. So this is how we use the symbol belonging and not belonging. We quickly go to question number 3. In the question number 3, they say, write the following set in roster form. So they give us, as I told you earlier, that there are two forms. One is a roster form and one is a set builder form. In this question, they give us a question in set builder form and they ask us to write it in roster form. That means like this, you have to list it and you have to get the answer. So this is our question number 3. In the question number 3, they have given us the collections in roster form, in set builder form, but we should list it in roster form. So the set A is a set of all those, they write X and then the set of all the integers which is between -3 and 7. That is what is being given in the collection, set of all X such that X is an integer and it is lying between -3 and 7. Now -3 and 7 is not included because the inequalities are strict inequalities, so you don't have them included. So what is it? It's very clear to us that it is an integer and it is some integer between -3 and 7. So let's start listing. Between -3 and 7, the set A could be written as -3 is not included. So if you want, you can have this in your mind. -3 less than X less than 7. So let's start listing. -3 is not there. So what comes after that? -2 on the number line. Then we have -1. Then we have 0. We have 1. We have 2. We have 3. We have 4. We have 5. And we have to stop at 6 because you are only allowed to take the integers and it's a strict inequality. 7 cannot be included. So this is the roster form for the set A. Quickly, let's see what's the next set. Set B is a set of all the X such that X is a natural number less than 6. X is a natural number less than 6 means you have to write all the natural numbers which are less than 6. So the natural numbers less than 6. So we'll take 1, we'll take 2, 3, 4 and 5 because it has to be less than 6. They have not told us less than equal to. They have only told less than. So we have to take only till 5. So these are the elements. We have the third collection, third set. What is it all about? Set of all the X such that X is a 2-digit number such that the sum of the digits is 8. Interesting. say X is a it's a 2-digit number. You can write only 2-digit numbers, but these 2-digit numbers should be such that when you sum up the digits, the sum should come to 8. Something like 17. 17, if you add 1 plus 7, it comes to 8, like that. So let's right away start from 2-digit numbers which should be summing up to 8. First is 17, as I said. What could be next? If you could go for a digit that is starting with 2, obviously it has to be, because it has to come to 8, it has to be 26. Start with 3. It could be 35. Start with 4, it has to be 44. Start with 5, it has to be 53. Start with 6, it has to be 62. Start with 7, it has to be 71, and obviously 80 also. Because 8 and 0 can add up to give you 80. So these are all the digits, as they have said that which should be a 2-digit number, but it should sum up to 80. So yeah, it should sum to 8. Then we have the fourth subpart where they give us a set D such that it's a set of all X such that X is a prime number which is a divisor of 60. Now 60 has got very many divisors, but you have to have only those numbers which are prime. Okay, so basically if we have that little bit of rough work for us, then 60 we know it can be 10 into 6, or it can be 12 into 5, or it can be maybe 2 into 30, or maybe it can be maybe 15 into 4, and many such, or maybe it can be 3 into 20. You know, when we try to factorize it, you get so many factors. But out of these, you can pick up only those which are prime numbers, because it's been given as a condition that should be prime number and should be divisor of 60. So which all are possible over here? You could have a 2, you could have a 3, you could have a 5. All others are appearing to be not prime. So therefore, in this collection, you could have 2, 3 and 5. So that's about the prime number list that they have told us. Okay, quickly move to the fifth subpart. In the fifth subpart, they ask us a set E such that E is a set of all letters in the word trigonometry. No, that's very easy. Just list up all the alphabets. Just check if there's a repetition, then we need not list it down. So trigonometry, we will be listing up the alphabets. E, trigonometry, T, R, I, G, O, N, O again, but that because we don't consider repetitions, M, E, T we will not write, R we will not write, and then Y. That's about it. That we have T, R, I, G, O, N, M, E, Y. Yes, those are the elements that has to be listed. Now in the sixth subpart, they ask us, it's a set F, where the set of all the letters of the word better. Same thing, we cannot have repetitions. So better. B, E, T, again T cannot be written, again E cannot be written, R can be written. So we have only B, E, T, R. So that is about the question number 3, where we have now learned how to convert a set builder into a listing method or a roster method. A given question in a set builder form, we have converted it into a roster form. This is about the thing. Thank you, and the remaining part we will be doing in the next video, part 3. Thank you.